Okay, we're continuing with the topic of inequalities. And this is a very good time to introduce the concept of absolute value. So absolute value can be defined a couple of different ways. There's an informal definition of absolute value and a very mathematical and formal definition. So I want to discuss both of those before I jump right into absolute value inequalities. So let's start with the definition of absolute value. So absolute value is really defined as the distance from the number, whatever number you're looking at, to the origin. And in the case of the real number line, the origin is 0. So we use the symbols absolute value by using these two vertical bars. And if I said, what's the absolute value of 2? We would maybe take a look at the real number line. We would come over here and take a look at the number 2. We'll highlight the number 2. And we're going to measure distance. Now, traditionally, measurements are positive. So if you measure using a ruler, a tape measure, the odometer in your car, it's a positive measurement. No matter which direction you go, you get a positive number from these measuring instruments. So we're going to measure up here with a tape measure to the origin. And of course, we would look at the tape measure, and it would measure 2. And so the absolute value of 2 is simply 2. We can do the same thing with a negative number. Let's do the absolute value of negative 3. And same thing. Let's get a number line here. 0, negative 1, negative 2, negative 3. Here's our 1 over here. Let's highlight negative 3. Let's get the tape measure out. We'll start the tape measure. It doesn't matter if you start from the left or the right, but we're going to measure to the origin, and that tape measure would say 3 on it. So the absolute value of negative 3 is 3. So now for the informal definition. Absolute value strips away minus signs. Informally, that's what it does. If there's a minus sign, it strips it away. So the absolute value of 2 is 2. The absolute value of negative 7, strip away that minus sign, is 7. The absolute value of minus pi is pi. So it strips away minus signs in a very informal way. It's a great way to say what it's doing. But we need to say it more formally. We need to know what's going on behind the scenes mathematically. So we need a definition, a formal definition. In fact, this formal definition will help us solve absolute value equations and absolute value inequalities. So this is the more formal definition. The absolute value of any unknown quantity is sometimes just that unknown quantity. In fact, sometimes the absolute value is pretty boring. It doesn't do anything. We could see it didn't do anything here. It just gave us what's inside. So sometimes the absolute value of x is simply x. And it's a boring function. It doesn't do anything when the x is already positive. And that would be when x is greater than or equal to 0. So it was already positive, and therefore it didn't have a job to do. But when that unknown x happens to be negative, it has a job to do. So how do we put in here mathematically to strip away a minus sign? Well, you might be surprised to know that the way to do that is to add an extra minus sign, like that. So that's the formal definition. The absolute value has two different modalities, basically. One doesn't do anything. It's already positive. The second is to put an extra minus sign in front of an already negative quantity. Double negatives cancel out, and you get your positive result. So that's a great way to think about that. That's the formal and informal definition of absolute values. So how do we solve an absolute value equation? Let's do one. Let's say we had 2x plus 1 is equal to 5. Now, first of all, hopefully you know right away that the equation would have no solution if it said the absolute value of something is negative. No way, right? The absolute value is always positive. So for those, we kind of quickly know that there's no solution. How could the absolute value be equal to a negative number? Sometimes you have equations like that, and you would say no solution. But the absolute value leads a dual life. Sometimes when the contents are positive, contents means all this stuff, whenever this computes to be a positive number, absolute value says, I don't really have a job to do. I'm just going to give you what's inside, and then you can solve accordingly. And you just solve it like you would any linear equation. Here's a solution right here. So you want to test that solution, plug it back into the original. 2 times 2 is 4, plus 1 is 5. The absolute value of 5 is truly 5, so that is correct. But what happens when the contents are negative? So if what's inside happens to be negative, let's see what happens here. Oh, that's right. We're supposed to add an extra minus sign to counteract the notion that this thing might be negative. Now, we don't have to talk about when it's positive and when it's negative. We just have to think about both possibilities. Now, in the second case, it will add a minus sign to counter this negative quantity. You know, like if x was negative 2, this expression here would be negative 3, so we would need that extra minus sign to counter that. Now, you can do one of two things. You can distribute the negative sign through both of these, or probably a better way is get rid of it right away by dividing both sides by negative 1. It makes it a lot cleaner if you do that. And solve the resulting equation. So we've got 2x is equal to minus 6, divide by 2, and here is my second solution, one that is not quite as obvious as the first one. Let's check that one out. Negative 3, is that really an answer? Let's try it. 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. And the absolute value of negative 5 truly is 5. It's correct. So that's the way that you solve an absolute value equation. Now I want to talk about solving an absolute value inequality. Inequalities are a little more interesting. In fact, there's many more solutions to an inequality than there is an absolute value equation. There's only 2 solutions, and generally you should find 2. So, also I would recommend checking the absolute value equation, because what if it did say the absolute value of, what did we have here, 2x plus 1 is equal to, what if it said negative 5? You would go through these 2 procedures and you would get 2 answers, but they would be extraneous. They can't be right. So it's always a good idea to check your answer, or if you want, just check up front that it doesn't say equals a negative quantity, because there's no solution to that. So I would either check the answer or check for absolute value equals negative and say, nope, no solution to that, and continue. Let's look at inequalities. Absolute value inequalities. So, what if we had an absolute value inequality like this? It said the absolute value of x is less than, let's say, 2. The absolute value leads 2 lives, right? In one situation, when this x is positive, absolute value doesn't have anything to do. It just pops out the quantity inside, and we'll get x is less than 2. In the other situation, and remember, all the action, all the activity takes place over here. If what's inside is negative, let's say x is negative 2, negative 3, negative 4, the absolute value takes care of that by adding an extra minus sign in front of it. So here is my solution. All the numbers less than 2, and what's that thing worth? What does that mean over there? Let's fix this. This should not be a negative x. It should be the letter x all by itself on the left. And to fix that, we're going to divide both sides by minus 1. Now, while we're doing that, I want you to notice that you just divided by a negative quantity, triggering the reversal of the inequality symbol. So I'm going to get x is greater than negative 2, actually. So this is really the solution set. And let's take a look at what this means. All numbers less than 2 and greater than negative 2 at the same time. If you were to take these 2 solutions and try to merge them together, maybe what we could do is pull this one aside, bring it down here, and rotate it. So actually, when we rotate, I like to put it in a clear plexiglass screen here and bring that off the board and rotate it. And if I did, this will go underneath. The -2 would rotate over here. This symbol would rotate like that. And the x would rotate, but x is just x. Sorry about that. It's just less than. Now, what if we took this equivalent version and we squeezed these two together? Watch what happens. And there's a great way to express your solution set. Here's another way to express your solution set. The endpoints are not included, so we will not include them with a nice soft edge. We'll bold up everything in the middle here. And certainly, you know there's one more way to express your solution set. Now, I know it looks like an ordered pair, but in the context of interval notation, we know that is not an ordered pair. That would be the interval notation version. What about a shortcut? I've got a great shortcut for solving absolute value inequalities that use less than, like the one we just did. This one makes it go much more quickly. So let's go back to the original. And this only works for the less than case. So absolute value of x is less than 2. Only works for the less than case. What we do is we say, yes, indeed, we get the original inequality here when the thing inside is positive. We just get that. But all you got to do is copy this less than inequality symbol, copy the number 2 over here, but a negative version, and you're done. Isn't that a quicker way to do it? It really is. So it's a great way to do absolute value inequalities for less than problems. Doesn't work for greater than problems. So let's look at a greater than problem and figure out. We would call this a one-interval solution. That's a one-interval solution. Because there is only one interval. All the numbers between -2 and 2. Okay, guys, let's take a look at a two-interval solution. Let's do the absolute value of 2x plus 1 is greater than or equal to, how about 9? This one you've got to do the hard way. There's two different outputs for absolute value. One output is simply what's underneath those absolute value symbols or inside. You solve it accordingly. So I'm going to go ahead and solve that for you. X is greater than or equal to 4. And sometimes it has to negate an already negative quantity. Remember, the action has to start on the left side. It does. And you're probably saying 2x plus 1 doesn't look negative. Well, if x is -7, it certainly is a negative quantity. So sometimes 2x plus 1 is negative. I would immediately divide by -1. Makes it a lot easier rather than distributing. And you get 2x plus 1. You get -9. Hey, we just divided by a negative number. That triggers the reversal of the inequality symbol. Subtract 1 from both sides. I get 2x is less than or equal to -10. Divide by 2. And I get x is less than or equal to -5, also part of my solution. And I have to connect these with the word or. There's just no way that you're going to get a number that is both bigger than 4 and less than -5 at the same time. That's not going to work. So on a number line, what does it look like? A two-interval solution? Well, let's put our 0 here and march out to 1, 2, 3, 4 here. And a hard edge bracket, because 4 is included, and all the numbers bigger than 4. There we go, and I'll put this big bold arrow over here, because you notice that the arrow points to the right, and the arrow points to the right. But let's come on over here to -1, -2, -3, -4, -5, -6, and same thing. Arrow points to the left this time, so we'll bold up the arrow to the left. Hard edge, because it's included. And we just found our two-interval solution, guys. So there's one-interval solutions and two-interval solutions. Let me finish by using interval notation. And I got to be careful here because that should be a nice hard edge. And so should this one. So what do you think goes in here, guys? If you look at it, you got a minus 5 over there, and way over here is negative infinity. Over here is the number 4, and way over here is positive infinity. And you can say, or, it's a two-interval solution. Okay. Now, the last thing I want to discuss when it comes to absolute value inequalities is how do you go from just expressing the interval on a number line like that and rewriting it as an absolute value inequality. And I'm going to show you how to do that on this particular example. Or maybe we'll pick another example here because I want to get some number. Well, we could do this example. Okay, let's do this one. So I want to show you how to rewrite it as an absolute value inequality, and all you get is this right here. So how do we do that? First thing I think you should discover when you have, and it could be this, or it could turn in on itself as well. Now think about the difference between those two cases. So let's line this up with minus 5, and let's turn it in on itself and have a one-interval solution. Let's put our 4 here. So this is a completely opposite answer to the original. How many solutions in our solution set, how many numbers are involved? Well, a lot. Minus 5, minus 6, minus 7, minus 8, 9, 10, 1,000, 1,000,000, all the way out to minus infinity. And over here, you have 4, 5, 6, 7, 8, 9, 10, 100, 1,000, 1,000,000. So think a lot of answers. And when you think a lot of answers, think greater than. Greater than means a lot. How many answers are over here? They're really, even though there are infinite number of real numbers in here, there's not a lot of answers to think about. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So that's a small number of answers by comparison. Small think, less than. So immediately you know which symbol to use. If it's a two-interval solution, there's a lot of answers, use greater than. If it's a one-interval solution, there aren't that many solutions by comparison. So think small, think less than. Now we are up here, so we're going to have to use greater than. So here comes the absolute value inequality we're about to create. It turns out that you can use this handy formula. X minus the midpoint is either less than or greater than or equal to distance over 2. So I guess what we need to do here, guys, it doesn't matter in either case, is we got to find the midpoint and we got to find the distance. Now, if you were to label this maybe as A, label this over here as B, distance is just the difference, B minus A. Just subtract the two. Now, distance is supposed to be positive, so, let's make sure it's positive, and absolute value does a great job on that. So my distance will be the absolute value of B minus A. So my distance will be the absolute value of 4 plus 5. My distance will be 9. And that certainly makes sense. The distance between these 2 points is 9. Midpoint. The midpoint is the average of those two numbers. So let's do midpoint. Midpoint is nothing more than the average. And how do you average? Just the same way you would average 2 test scores together. You add them together and divide by 2. And you don't need an absolute value for that. So let's add them together. That would be 4 plus the number minus 5 divided by 2. So what do we get for midpoint? 4 minus 5 over 2. The midpoint between those two numbers is minus 1/2. And that's all you need to recreate the original inequality. Let's look at it one more time. X minus midpoint greater than two-interval solution, lots